Download this code from codegive.com, link in the description below. OK, let's dive into the world of blocking and deadlocks in SQL Server. This is a common challenge in multi-user database environments, and understanding how they occur and how to mitigate them is crucial for performance and stability. Introduction: Understanding concurrency and locking. In a database system like SQL Server, multiple users and applications often need to access and modify the same data concurrently. To maintain data integrity and consistency, the database engine uses a system of locking. Locks prevent multiple transactions from modifying the same data in a way that could lead to corruption or inconsistent results. Types of locks. SQL Server uses different types of locks with varying levels of restrictiveness. Shared locks allow multiple transactions to read the same data simultaneously. A shared lock is acquired when a transaction reads data. Other transactions can acquire shared locks on the same data. Exclusive locks prevent any other transaction from accessing the data at all. An exclusive lock is acquired when a transaction modifies data, inserts, updates, deletes. Only one transaction can hold an exclusive lock on a resource at a time. Update locks a special lock used before modifying data. It is compatible with shared locks but prevents other transactions from acquiring shared or update locks. It is promoted to an exclusive lock when the transaction actually modifies the data. Intent locks, IU9 indicate that a transaction intends to acquire a shared, update, or exclusive lock on resources lower in the hierarchy, example a table if the intent lock is on a database. These locks exist to optimize lock escalation and prevent conflicts higher up in the resource hierarchy. Schema locks, SCHM used during schema modifications, example creating or altering a table. Schema stability, SCHS, locks prevent data modification during schema operations. Schema modification, SCHM, locks prevent all access to the table during schema modification. Bulk update, bulletin, locks used during bulk copy operations. Lock hierarchy *. SQL Server uses a hierarchical locking system. Locks can be acquired at different levels. Database affects the entire database. Table affects an entire table. Page a unit of storage within a data file, typically 8 KB. Row affects a specific row in a table. Key affects an index key. Metadata affects database objects such as tables, stored procedures, etc. 2. Blocking, when locks cause delays. Blocking occurs when one transaction holds a lock on a resource, example a row, a table, and another transaction attempts to acquire a conflicting lock on the same resource. The second transaction will be blocked until the first transaction releases its lock. Blocking is a normal and expected behavior in a multi-user database system. However, excessive or long-lasting blocking can significantly degrade performance. Causes of blocking long-running transactions transactions that take a long time to complete, example complex queries, large batch updates, hold locks for longer periods, increasing the likelihood of blocking. Lack of proper indexing when queries lack appropriate indexes, SQL Server might need to scan entire tables, requiring locks on a large number of rows, which can lead to blocking. Deadlocks, explained later. Deadlocks are a special case of blocking that can cause severe performance problems. Application design. Poorly designed applications might hold locks unnecessarily or for longer durations than required. Asterisk inappropriate isolation levels. Asterisk isolation levels determine the degree to which transactions are isolated from each other. More restrictive isolation levels, example serializable, can increase blocking. Example of blocking asterisk. Let's create a simple example using 2 SQL Server Management Studio, SSMS, Windows. Setup asterisk. Window 1 asterisk. Window 2 asterisk. In this scenario, transaction 1 acquires an exclusive lock on the row where product name equals product A. Transaction 2 attempts to acquire an exclusive lock on the same row. Since transaction 1 holds the lock, transaction 2 is blocked. If you execute the query in window 2, it will hang indefinitely until you commit or roll back the transaction in window 1. Resolving blocking, in this example. In window 1, either or. 3. Deadlocks, a deadly embrace. A deadlock is a specific type of blocking scenario where 2 or more transactions are blocked indefinitely, each waiting for the other to release a resource that it needs. It's a circular dependency. Example of a deadlock asterisk. Window 1 asterisk. Window 2 asterisk. What happens asterisk? 1 Transaction 1 acquires an exclusive lock on the row with product ID equals 1. 2 Transaction 2 acquires an exclusive lock on the row with product ID equals 3. 3 Transaction 1 attempts to acquire an exclusive lock on the row with product ID equals 3, but it's blocked by Transaction 2. 4 Transaction 2 attempts to acquire an exclusive lock on the row with product ID equals 1, but it's blocked by Transaction 1. 5 Deadlock, each transaction is waiting for the other to release the lock it needs. SQL Server's deadlock detection and resolution asterisk. SQL Server has a built-in deadlock monitor. This monitor periodically checks for deadlocks. When a deadlock is detected, SQL Server chooses one of the transactions as the deadlock victim and rolls back that transaction. The application receives an error message, error 1205, indicating that the transaction was terminated as a deadlock victim. The other transaction, S, are allowed to proceed. Deadlock prevention and mitigation asterisk. The best approach is to prevent deadlocks from occurring in the first place. Here are several strategies. 1 Consistent access order asterisk. The most common and effective technique is to ensure that transactions access tables, and even rows within tables, in the same order. If all transactions always access tables A, then B, then C, the likelihood of a deadlock is greatly reduced. In the previous example, accessing product ID 1 before 3 in both transactions would prevent the deadlock. 2 Keep transactions short and fast asterisk. Shorter transactions hold locks for shorter durations, reducing the window of opportunity for deadlocks. Break down large transactions into smaller ones if possible. 3 Use appropriate isolation levels asterisk. Lower isolation levels, example read committed snapshot or read uncommitted, can reduce blocking and deadlocks, but at the cost of potentially reading uncommitted data. Carefully consider the trade-offs. The default read committed isolation level can often be optimized. 4 Use indexes effectively asterisk. Proper indexes allow SQL Server to quickly locate the data it needs, reducing the duration of lock contention. 5 Avoid user interaction during transactions asterisk. Do not involve user input within a transaction, example prompting a user for confirmation. This can lead to very long-running transactions and increased blocking. 6 Use lower lock granularity asterisk. Consider row-level locking if appropriate for your application. This can reduce contention compared to page or table-level locking. SQL Server often uses row-level locking by default, but lock escalation can occur if a transaction modifies a large number of rows, escalating to a table lock. 7. Retry logic in applications *. Since a transaction might be chosen as a deadlock victim, implement retry logic in your applications. When a deadlock error 1205, occurs, the application should roll back the transaction and retry it after a short delay. 8. Consider using snapshot isolation *. Snapshot isolation can eliminate blocking between readers and writers. However, it introduces a potential for update conflicts, where a transaction tries to commit changes based on data that has since been modified by another transaction. 4. Monitoring and diagnosing blocking and deadlocks. SQL Server provides several tools and techniques for monitoring and diagnosing blocking and deadlocks. 1. Activity Monitor in SSMS * provides a graphical overview of active processes, resource waits, and blocking. 2. SP_who and SP_who 2 * system stored procedures that show current SQL Server users and processes. They can help identify blocked processes. Look for a blocked column. SP_who 2 is an undocumented but widely used extended version of SP_who. 3. sys.dm_exec_requests Dynamic Management View, DMV provides detailed information about active requests, including wait types, blocking session IDs, and SQL text. 4. sys.dm_os_waiting_tasks DMV * shows tasks that are currently waiting for resources. 5. Extended Events Events a powerful and flexible system for capturing detailed information about database events, including blocking and deadlocks. This is generally preferred over SQL Profiler. *system_health session * SQL Server automatically includes a system_health extended events session that captures basic deadlock information, example in the form of XML. You can view this information using SSMS. Custom X event sessions You can create custom X event sessions to capture more specific deadlock information, including the deadlock graph, which visually represents the transactions and resources involved in a deadlock. 6. SQL Profiler, deprecated, but still useful to know, an older tool for capturing SQL Server events. It can be used to capture deadlock events, but extended events are generally preferred due to lower overhead. Analyzing deadlock graphs. The deadlock graph is a powerful tool for understanding the cause of a deadlock. It's an XML document that visually represents the transactions, resources, and locks involved in the deadlock. SSMS can display the deadlock graph in a graphical format, making it easier to analyze. Here's how to interpret a deadlock graph. Processes, transactions represented by nodes with information about the session ID, login name, and associated SQL text. Resources represented by nodes with information about the database, object, table, index, and page or row ID. Edges show the relationships between processes and resources. An edge from a process to a resource indicates that the process is waiting for a lock on that resource. An edge from a resource to a process indicates that the process is holding a lock on that resource. Deadlock victim the process that was chosen as the deadlock victim is usually marked clearly in the graph. By examining the deadlock graph, you can identify which transactions were involved in the deadlock, which resources were being contended for, the lock types involved, example exclusive, shared, the SQL statements that were executing when the deadlock occurred. This information is crucial for identifying the root cause of the deadlock and implementing appropriate mitigation strategies. 6. Best Practices Summary. Design for concurrency. Consider concurrency issues during application design. Asterisk consistent access order. Asterisk ensure transactions access tables in a consistent order. Asterisk short transactions. Asterisk keep transactions short and focused. Asterisk proper indexing. Asterisk use appropriate indexes to optimize query performance. Asterisk appropriate isolation levels. Asterisk carefully choose the appropriate isolation level. Asterisk retry logic. Asterisk implement retry logic in applications to handle deadlock errors. Asterisk monitor regularly. Asterisk monitor your SQL Server instance for blocking and deadlocks. Asterisk analyze deadlock graphs. Asterisk learn how to analyze deadlock graphs to identify the root cause of deadlocks. By understanding the principles of locking, blocking, and deadlocks, and by following these best practices, you can significantly reduce the likelihood of these issues and ensure the smooth operation of your SQL Server database. Remember to tailor your approach to the specific needs and characteristics of your application and database. Good luck.